Okay, so let's see if you have the math skills to solve this interesting little math word problem. Matter of fact, let me go ahead and read the problem. It is the following. The wind blew a 70-foot tall telephone pole 15 degrees off center. What is the new height of the pole? Okay, so that is the question. Feel free to use a calculator, but if you can figure this out, go ahead and put your answer into the comment section. I'll share the correct answer in just 1 second. And then, of course, I'm going to solve this problem step by step. But before we get started, let me quickly introduce myself. My name is John, and I have been teaching middle and high school math for decades. And it really is my true passion to try to make learning math as easy as possible. So if you need assistance in mathematics, check out my math help program at tcmathacademy.com. You can find a link to that in the description below. And if this video helps you out, or if you just enjoy this content, make sure to like and subscribe, as that definitely helps me out. All right, now before I show you the answer, let's just make sure you understand the question. So the wind blew this telephone pole, specifically this 70-foot telephone pole. Now, we have to assume that this pole is perpendicular to the ground. Okay, so we're going to make that assumption in this problem. And the wind came and blew that pole off center. In other words, it tilted off to the side 15 degrees. So we're looking for the new height of the pole. Okay, so that is the question. Now let's go ahead and take a look at the answer. The correct answer is the new height of the pole is approximately 67.61 feet. Okay, so how did you do? Well, if you got this right, we have to celebrate by giving you a nice little happy face and A plus a 100% and multiple stars. So you could brag to your friends and family that indeed you are a certified professional expert in solving right triangle word problems, because effectively that's what we're going to be doing here is we're going to be setting up a right triangle to basically model this situation, but we're also going to be using some basic trigonometry. So for those of you that figure this out, that is outstanding. And for those of you that are like, I have no idea what's going on, just stick with me for a couple minutes and you're going to learn a ton. And of course, you'll know exactly how to solve this problem as well. So let's go ahead and get into it. Now, the first thing we want to do when we're faced with any math word problem is to always read it at least 3 times. Just don't read a problem once and then start doing things. So if there's any confusion about the problem, and if any of you out there are students, raise your hand. Make sure you have clarification and you understand the problem precisely. Now, a great way to understand the problem and specifically the question is to model the problem and visualize it. And this type of problem is perfect for a nice, lovely little sketch. So let's go ahead and create a sketch of the situation. And again, we have this height of the pole. We're looking for this telephone pole that's bent over to the side. We're looking for its height. And let's go ahead and just come up with a quick sketch. And this is where math can be creative. Now, my sketch can look different than yours, but effectively, you need to have the same kind of model in mind in terms of interpreting the problem, right? So here is our lovely 70-foot tall telephone pole before the wind came. And then, of course, the wind came and blew this pole over to the side off center, right? Now, again, we want to assume that this pole is perpendicular to the ground initially, but then it was tilted or it blew off center 15 degrees. So here, this lovely line, this yellow line here, would indicate our pole's new position more or less. Okay, so this is like the before and this is the after. And of course, the height of the pole now is this perpendicular distance right here. Okay, it's this 70-foot pole is not 70 foot, the height of it is not no longer 70 feet, it's this distance. Okay, so what we're dealing with here is a little triangle. And if you could see that, well, then again, you can kind of see that we're going to be getting into a right triangle word problem. Because when we're talking about perpendicular, perpendicular means that two lines or line segments form a 90-degree angle. And if we could construct a triangle, or one of the angles is 90 degrees, we're dealing with a right triangle. Okay, and that's exactly what we're going to be, focusing in on here for this particular problem. Now, let's just kind of think about something here for a second. So this angle right here, it's kind of hard to see, it's small angle. This is 15 degrees. So if this is 15 degrees, what is the larger angle all the way down to the ground? Okay, so we have 15 degrees. So from here to here is how many degrees? Well, this entire angle right here is 90 degrees because this would be, again, from our original pole to the ground, that's 90 degrees. So this right here to here is 75 degrees, right? Would be 90 minus 15 or 75 degrees. So we're going to be focusing it in on this triangle. It's kind of hard to see, so let's go ahead and break this out this way. All right, so this is what we want to do is kind of interpret the problem in a very simple triangle and specifically a right triangle. All right, so here is our pole. It's still 70 feet. It's just tilted off to the side, but we're looking for this distance, which represents the height of that pole. Now, we already figured out that this angle is 75 degrees because if we continued on here, another 15 degrees would form that 90-degree right angle. So this is an important part of this problem is interpreting what's going on here. All right, so if there's any confusion how this triangle, this right triangle, and its information is derived, well, then you have to kind of study this crazy figure. Matter of fact, I have to kind of erase all this, or you can just kind of watch this video again to make sure you understand this part. Okay, so if you do understand what's going on here, well, basically our problem is more or less this problem now. Okay, so if we can find this distance, okay, this length of this right triangle, then we will have solved the problem. Okay, so what information do we have? Well, we have this angle here. Okay, we have this angle, we have this angle, and we know the sum of the angles in a triangle is 180 degrees. So we also have this angle as well, but we only have one length, and we're trying to find this length. So we have one length and a bunch of angles. So how can we solve this length right here? Now, if you're thinking, well, maybe I can use the Pythagorean theorem, that's fantastic. Okay, however, to solve for a length, any one length in a right triangle, we need to have at least two pieces of information, two lengths, to get the third length. And here we only have one length. Specifically, we have the hypotenuse. So we're not going to be able to use the Pythagorean theorem. So we're going to have to use some trigonometry. Now, I know a lot of you are saying, oh my goodness, trigonometry, Mr. YouTube Math Man, I'm not doing trigonometry. That's too hard. Well, if you've never done trigonometry before, then this is a great little intro to the subject. It's not that bad. Matter of fact, we're going to be talking about these buttons on your calculators, sine, cosine, and tangent. These are what we call basic trigonometric functions, and I'm going to explain to you in a second here what a trigonometric function is or trigonometric ratio is, because this is going to be the secret to solve this problem. So anytime you're trying to solve a right triangle word problem, and you only have one length, okay, and you just have angles, well, we're going to have to use some basic trigonometry to figure out the other lengths of the triangle. Okay, so let's go ahead and talk about that right now. And so let's take a look at a right triangle. Okay, now this right triangle has lengths, and it's 3, 4, and 5. This is actually called a Pythagorean theorem, or sorry, not Pythagorean theorem, a Pythagorean triple, excuse me. So, but we can use the Pythagorean theorem just to kind of prove that 3 squared, matter of fact, let's do this now, a squared plus b squared is equal to c squared. So 3 squared plus 4 squared is equal to 5 squared. Okay, remember c is always the longest side of a right triangle, and that is called the hypotenuse. Okay, so this relationship holds true, okay, or the relationship amongst the sides is defined by the Pythagorean theorem, okay, and of course we could solve for these sides if we were missing one, we could use the Pythagorean theorem to find the third. But I'm going to have all three sides here because the focus here is not to talk about the sides of these triangles, is to introduce you to some basic trigonometry. And we're going to be focusing in on this thing right here. Now, this is a phrase. It's going to sound kind of crazy, but I will fully explain it. And the phrase is so, ka, toa. So, ka, toa. Now, some of you are saying, okay, Mr. YouTube Math Man, you know what, you got me completely lost. I don't know what you're talking about. Now you're speaking a different language. Well, hold on one second. This is going to make perfect sense in about a minute or so. Okay, so SOHCAHTOA is how we define something called trigonometric ratios. But these things here, O, and A stand for something, and the S stands for sine. Okay, so if you look on your scientific calculator, we have this button sine. Okay, then we have another button called cosine, and we have another button called tangent. And sine, cosine, and tangent are defined as ratios, i.e., fractions that are constructed out of the sides of a right triangle. Now, those particular sides, we have to first understand what OH, AH, and OA are. Okay, so now I'm going to go ahead and tell you what those O, H, and A mean. Okay, so in this triangle here, we have this angle in this corner. Okay, now if you look opposite of the angle, we have 3. Okay, so if we have some angle here, this side of the triangle is called the opposite side. Okay, so in this case, this angle here, its opposite side is 3. Okay, now the angle right next to it, I'm sorry, the length right next to it is called the adjacent side. So this angle here, the adjacent side is right next to it, so it's this side. Okay, so when you're looking at an angle, the length opposite of it will be O. Now, of course, this could be different. If the angle's up here, the opposite would be over here. Okay, so you have to be careful that the O, A, and, well, the H is a little bit different. Matter of fact, let me tell you what the H is. The H is always the longest side in a right triangle. That's called the hypotenuse. Okay, so the longest side, which is always the opposite of the right angle, is the hypotenuse. So in this case, it's 5. Okay, that's the longest side. That's our H. But the O and A depend on where the angle's at. So one more time. So if our angle's right here, the opposite side is this side. So in this case, it would be 3, but it would be opposite of this angle. And then the adjacent side actually helps form the angle. In this case, it would be 4. Okay, so now that we know what the opposite, adjacent, and the hypotenuse, sides are in a right triangle, then we could define these trigonometric ratios. Okay, so let's go to take a look at that right now. So here is our lovely right triangle, and let's go ahead and define what the sine, cosine, and tangent mean. All right, so as I indicated, these are ratios, trigonometric ratios, which are effectively fractions. So the sine of an angle is equal to the opposite over the hypotenuse. So for example, right here, if I wanted to find the sine of this angle, okay, it would be equal to the opposite, which would be 3 over 5. Okay, so in other words, the sine of this angle here is equal to 3 over 5. Now, its usefulness, in other words, why do we want to, what does this, do for us? Well, I'll show you the application of this in a second, but let's just first make sure you understand what's going on here. Okay, so that's what the sine is. And once you understand that simple example, we can go ahead and define the rest. So the cosine, okay, is equal to the adjacent over the hypotenuse. So the cosine of this triangle right here, or this angle, would be 4 over 5. Okay, and then of course we have the tangent, and the tangent of the angle would be equal to the opposite over the adjacent. Okay, so these are the trigonometric ratios, the basic trigonometric ratios that we need to solve right triangle word prompts. Now, I'm going to go ahead and I'm going to show you how we can use this to actually find this length of this of our triangle in just 1 second. But before I take that step, I'm going to take this step, which is to ask for your support to subscribe to my channel. My objective is to find as many people as I can that need help in mathematics. Okay, that's my main goal. I've been on YouTube for 10 plus years. I've been doing this stuff for decades, and I wouldn't be doing things anything like this long if I wasn't truly passionate about helping people. On my YouTube channel, by the way, you'll find over 2,000 plus videos right now. And of course, I'm adding videos every day from basic math to advanced math like calculus and everything in between. But my objective is to find people that are interested in math but really need help in mathematics. There's far too many people that are like this and like, I hate math, I'm bad at math, and the reason why typically people do not like math is because they're frustrated by it, and that's easily, that's easily understandable. If you don't understand something, you're not going to like it. And typically, most people don't understand it because they're not getting adequate instruction. Okay, you got to get full comprehensive instruction. And another thing as well, if you are a student, there are no shortcuts. So if someone's trying to tell you, oh, you could take a shortcut, or here is a 2-minute video to understand trigonometry, well, you might get a quick tutorial, but you're never going to really know enough to handle a wide variety of prompts. I don't teach in that way because I'm very realistic. I teach you what you need to know. But anyways, I do need your help to grow my channel. So if you subscribe, okay, it does help me connect with those people that can benefit from my instruction. And go ahead and hit that notification bell as well so you can get my latest content. Thanks for listening to my little commercial here. Now back to the problem. Okay, so here's our situation. We have our right triangle, and we're looking for this side because this side right here of this right triangle represents the height of our pole. Okay, so it got tilted off 15 degrees. So here is our 70-foot pole, but the height of the pole off the ground is actually this distance right here. So we're trying to find this length. Okay, now we have this angle right here, and we have the length of the hypotenuse, which is 70 degrees. So what trigonometric function could we use to solve this problem? Well, the things in question are what? Well, if we have 75 degrees here, the thing that we're looking for, this distance, is what with respect to the 75 degrees? Well, it's actually the opposite side, right? This side is the opposite of the 75 degrees, but we also have the hypotenuse. So we have the opposite, and we have the hypotenuse, and we have the angle. So which trigonometric function involves the opposite and the hypotenuse? That, of course, would be sine. So we want to use sine. We have different options here. We can use cosine or tangent, but we don't have enough information for all of those, so we have to use the trigonometric function that we have the information for. And of course, we're looking for this unknown value right here, which is the opposite side of this right triangle. So we're going to use sine to set up a trigonometric ratio, and you're going to see exactly how we solve this problem in just 1 second. Okay, so here we go. So now that we know that we're going to use sine, remember sine of an angle is equal to the opposite over the hypotenuse. So the sine of this 75 degrees is going to be equal to its opposite, which is, of course, x. We don't know what that is. So x is the opposite. And the hypotenuse, of course, is 70. So sine of 75 degrees is equal to the opposite, which is x, okay, over the hypotenuse, which is 70. Okay, so if you understand this, then effectively all we have to do is break out our calculators and solve for x. Okay, so sine of 75 degrees is equal to x over 70. We could just think of this as a simple proportion. In other words, we're going to put this over 1. So we have one fraction equal to another fraction. We can simply just use the cross product here to solve for x. So x times 1 is x. Okay, let me go ahead and scroll down here. So x times 1 is x. And 70 times sine of 75 will be this. So you want to go into your calculator. You can just type this in, 70 times sine of 75 degrees. Make sure your calculator is in degree mode. Now, when you study trigonometry, you can define angles as degrees or something called radians. Now, for those of you that will be taking more advanced trigonometry, we'll be using a ton or be doing a ton of problems in radians. It's very, very common. So what happens is students switch back and forth between these modes as they need to, but they forget to go back in the proper mode when they do a problem. So for example, a student could be like, oh, I just did a problem. It was in radians on my calculator, and I forgot to switch back to degree mode. I have seen this countless times where students are so sad. They did everything right, but they weren't in degree mode, and then they get their problem wrong. Okay, but the good news is for those of you that are like, I don't even know what you're talking about, don't worry about it because your calculator will always be in degree mode as a default. But for those of you that are, taking geometry or trigonometry, you got to be very mindful of this because I've seen too many tears throughout the years where people forgetting to make sure their calculator is in a proper mode. Okay, so now that you know that your calculator is in degree mode, you can just take 70 and multiply it by sine 75 degrees, and you're going to get approximately 67.61. But what does that mean? Well, that's 67.61 feet. So we kind of go back up here to our lovely model here, right? So here is our pole. So this is about 67.61 feet in terms of the height of the pole. Okay, so I know a lot of you are probably like exhausted from this video, like, oh my goodness, Mr. YouTube Math Man, you really just kind of fried my brain with all this new information. Well, listen, I did throw a lot, at you if you've never seen this before. But for those of you that are like, yes, indeed, I understand this, maybe I forgot this. Well, this is a kind of quick review. But for those of you that want to learn this or need assistance in this because you're learning it for the first time, let me give you a couple quick suggestions. One, check out my main courses. You'll find links to them in the description of the video. If you are studying, say, geometry, check out my full geometry course. In there, there is a chapter, some sections on basic trigonometry. If you are in full trigonometry, then you have to check out my pre-calculus course because I'm going to teach you this and much more advanced trigonometry. And for those of you that just kind of want to learn some basic math, some algebra, and some basic trigonometry and probability and statistics just because you're kind of curious, or maybe you just want to revisit your math skills that you forgot many years ago. Check out my new course. It's called my Math Skills Rebuilder course. You'll find links to all these courses in the description. Okay, so with all that being said, I definitely wish you all the best in your mathematics adventures. Thank you for your time and have a great day.